Okay guys, so this is going to be evaluating limits graphically. This is just going to be a little introductory lesson to limits to get you ready for calculus. Okay, in order for a limit to exist, the left-hand limit must equal the right-hand limit. We write this in the following notation. Okay, so let's zoom in just a little bit. Okay, so we can make sure so this is read the limit as x approaches a from the left-hand side, okay? So the negative, that's not a negative a, that's from the left-hand side of f of x, so that's called the left-hand limit. The limit as x approaches a from the positive side, which is the right-hand limit, okay? So left-hand side, right-hand side. So in order for a limit to exist, they must approach the same value, okay? So number one, it says we're going to evaluate the limit as x approaches -3 from the negative side, from the left-hand side. Okay, so I'm going to come along the curve to x is equal to a -3, and I'm going to look at what the y value is. Even if it's a hole, a limit can be, it can have a hole. So it looks like it has a y value of 0. Okay, as I come from the right-hand side of the curve of this piecewise function, the y value looks like it is 6. Okay. Now, since these two numbers don't equal each other, the limit does not exist. F of -3 is looking for what is the solid point at x is equal to a -3. So it's going to be -4. Okay. Number 5. Now it says we're going to look at the limit as x approaches 5 from both sides. So x is equal to 5. 1, 2, 3, 4, 5. So it's this asymptote right here. Okay. So the limit as x goes to 5 from the left-hand side, it's going to approach positive infinity. Okay, the limit as x approaches 5 from the right-hand side. So as I come from the right-hand side of the graph, it's going to go to negative infinity. Okay. Since these two limits don't equal each other, it does not exist. And f of 5 does not exist because it's on an asymptote. Okay, there's no solid points on there. Just an FYI, technically limits cannot equal to infinity because infinity is not a number, it's a behavior. So if you were to write, say this one came out to be positive infinity also. If you were to write that the limit as x approaches 5 was positive infinity, I would not count that wrong. But usually like on an AP exam, they'll give you one choice. So you can say does not exist and then like parentheses put positive infinity. That's fine with me. Okay, so the limit as x approaches -1 from the left-hand side. So x approaches -1 is this line right here. So as I come from the left-hand side, my y value is -2. As I come from the right-hand side of the graph, my y value is equal to a -2. Since the left-hand limit equals the right-hand limit, so the left-hand limit equals the right-hand limit, the limit is equal to a -2. Now, f of -1, there's no colored in point right here. So we have to say it does not exist. Okay, I'm going to zoom back out so we can get a whole picture. Okay. The limit as x approaches 2 from the left-hand side. So 2 is right here. So it looks like it has a y value of 1. Okay. As I come from the right-hand side, my y value is 1. Okay. Now, since the left-hand limit equals the right-hand limit, that means the limit as x approaches 2 is also 1. And f of 2 is 1. That's a solid point right there. Now, the way I look at it is if your fingers meet up at the same point, the limit exists, okay? So there's no jumps in the graph. If we're looking at this over here, when we're looking at x is equal to a -3, this is called a jump discontinuity, when there's a jump in the graph. Okay, so just keep that in mind. The limit as x approaches positive infinity, so all the way out to the right. It looks like it's going to line out to 0. Okay? And as I go to negative infinity, it looks like it's going to line out to -3. Okay? So whenever you're doing limits at infinity, those are going to be your horizontal asymptotes. Okay, so we're looking for what it lines out to as it goes all the way to the left and all the way to the right. Okay, let's look at another one. Okay, the limit as x approaches -6. Okay, so as I come from the left-hand side, it has a y value of -2. As I come from the right-hand side, it has a y value of -2. So since the left-hand limit equals the right-hand limit, this is also equal to a -2. And then f of -6 is 2. So that solid point up there. The limit as x approaches -4 from the left side. Okay, so -4 from the left side is right here. That looks like it's 3. Okay, as I come from the right-hand side, the limit is 3. So since the left-hand limit equals the right-hand limit, this is also equal to 3. F of -4 is 3. Now, because there's a solid point right there. 9, the limit as x approaches -1 from the left-hand side. So -1 is this line right here, the asymptote. So as I go from the left-hand side, it's going to go down to -infinity. As I go from the right-hand side, it's going to go to -infinity. And this is what I was talking about in the previous example. Since these both are going to -infinity, I can say does not exist or -infinity. Okay, they're both going the same direction. And then f of -1 does not exist because it's an asymptote, a vertical asymptote. Okay, the limit as x approaches -2 from the left-hand side, so -2 is right here. So as I go from the left-hand side, my y value is 4. As I come from the right-hand side, my y value looks like it's 0. Since the left-hand limit does not equal the right-hand limit, this does not exist. F of -2, we're looking for the solid point. Okay, so it's going to be 4. Okay, the limit as x approaches infinity, so all the way out to the right, what does it line out to? And it looks like it lines out to 1. And as I go all the way out to the left, so as I go all the way out to the left, I'm following my graph, it's going to go all the way up to positive infinity. Okay? So that's how we do limits graphically. We're going to go on and do another example, but these are going to be a little bit shorter. You will actually see these types of questions that look a little more like this in your calculus books. So f of -2. Okay, it's on a asymptote, so this is going to be does not exist. The limit as x approaches -2. Okay, so as I come from the left-hand side, it goes to -infinity. So I'm just going to go ahead and do all my parts just to get in the habit. And then as I go from the right-hand side, it goes to positive infinity. So this is going to be does not exist for part B. I should have went down there and did that. Okay, f of 0. Looking for the solid point at x is equal to 0, so it's 4. Okay, and I'm going to go down here and do part D. Okay, now you want to prove the limit at x is equal to 0. So we say the limit as x approaches 0 from the left-hand side, that looks like it's going to be 1/2. The limit as x approaches 0 from the right-hand side, as I come from the right-hand side, is 4. So that means that the limit as x approaches 0 does not exist. Okay, since the left-hand limit does not equal the right-hand limit. Okay, E, f of 2. F of 2 is not a solid point, so it does not exist. But the limit might exist, but f of 2 does not exist. Okay, so let's do f. The limit as x approaches 2 from the left-hand side, okay, is 1/2. The limit as x approaches 2 from the right-hand side is 1/2. Since the left-hand limit equals the right-hand limit, the limit as x approaches 2 is equal to 1/2. And if you're going to ask me if you have to do this every single time, yes, you do. Okay? Until you are a pro at this stuff. Okay, f of 4 is equal to 2. We're looking for the solid point at x is equal to 4, so it's this point right here. And h. So we'll take the limit as x approaches 4 from the left-hand side. Okay, so it's going to go up to positive infinity. The limit as x approaches 4 from the right-hand side is also positive infinity because it's going up. Okay, so the limit as x approaches 4 of f of x does not exist, but they both go to positive infinity if you want to describe the behavior. Okay? And last example problem. A little bit shorter. Okay, so f of 1, I'm looking for the solid point, so it's going to be equal to 2. F of 1 is equal to 2. The limit as x approaches 1. Okay, so let's do part B down here. So we'll do the limit as x approaches 1 from the left-hand side. The limit as x approaches 1 from the right-hand side, and if they equal each other. Okay, so the limit as x approaches 1 from the left-hand side. So I come from the left-hand side, it looks like it has a y value of, 3.5, say 3.5. As I come from the right-hand side, the y value is 1. They don't equal each other, so it does not exist. Okay, so f of 4. F of 4 is right here. There's an open circle, so it does not exist. So f of has to be a solid point. And then D, part D. The limit as x approaches 4 of f of x from the negative side. And do the limit as x approaches 4 from the positive side. Okay, so the limit as x approaches 4 from the left side is going to be 2. As I come from the right-hand side, it's 2. And so since they're equal to each other, the limit as x approaches 4 is also equal to 2. Okay, so this has been limits graphically. In the next lesson, we'll take a look at how to evaluate these using algebra methods, and that's called analytical limits. So hopefully this made a little more sense to you. Some of you, this is the second time you've seen it, but you will use this in calculus, and we will go through this quickly. So everything from limits to continuity, and especially logs in your trig chart, you need to make sure you know come day 1 of calculus. So this has been Graphical Limits. Thanks, and have a good day.